This lecture is about AAA, authentication, authorization, and accounting. This is a very important topic on security. Now, every slide of this lecture has a Wikipedia pointer, so you will use Wikipedia to find out more about these topics. So, AAA has several parts. First is the RADIUS that we'll talk about next. Then several authentication protocols that were used in the past, and then we made EAP, which is Extensible Authentication Protocol, and then we go to 82.1x. So basically three things: EAP, 82.1x, RADIUS, and fourth is the other protocols. So RADIUS came into being when basically people started going from one region of the one country to the other, and they still wanted to use their original ISP account. So if you are here and you have an AT&T account and you go to Germany and you want to use some carrier which is related to AT&T, how do they authenticate that you are you? Right? This is similar to the single sign-on. This is similar to the, what did we say? We called it federated identity. So maybe this would be called first step in federated identity. So the idea is that the user is here and it is connected to an ISP which does not have your authentication data. And there is the authentication data is kept on a separate server which is called RADIUS server. RADIUS stands for Remote Authentication Dial-in User Service. So that dial-in came in because that was the time it was invented. It is used even today whether you dial in or not. Dial-in is coming from the phone networking days when you used to dial in. So RADIUS server is very commonly used. In fact, this morning I received a message from our own department. I mean, if you are in computer science, you might have received this as well. From IT department, they are changing the RADIUS server, updating the RADIUS server, and so on and so forth. So they are used everywhere. RADIUS provides, obviously, AAA, it provides authorization, accounting, and auditing. So if you use, let's say, 3 hours of service in Germany, that accounting will be done here, so that you can be billed for it. Authentication obviously will be done to make sure that you are the person that you are saying. And then there is auditing. Auditing is basically logging. In case you question, then they will have a whole record of it. So auditing and accounting are somewhat similar. So this is called AAA server. And so the user says to this little device, a modem pool here, that I am Raj Jain, whatever, from St. Louis, Missouri, and I am an AT&T customer. I would just put Jain at AT&T, whatever. Then that modem pool will contact the RADIUS server and say, how do I authenticate Raj Jain? And then the rest of these things will proceed, and I will be authenticated. So we are going to talk about how all that will proceed. But first, the purpose of RADIUS. Basically federated identity. Now, so you can also have RADIUS proxy servers, before I go to this slide, where this data can be cached here. If you're going to be in Germany for a few days, they might as well remember your thing, although this is not necessary, and it may not be done if this ISP does not trust this ISP, to that extent. They don't want to share the password. While they want to share the financial account, but they may not want to share your password with them, right, or your authentication data, whatever that is. So the proxy server is allowed, and if there is a proxy RADIUS, then basically the ISP will be able to authenticate you from the proxy. Another point on the slide is that it uses UDP, and since it uses UDP, there are several conditions that it has to handle by itself, such as retransmissions, and so on and so forth. And they didn't want to use TCP because of, they didn't want to take that long to, always whenever some things are time sensitive, just like multimedia, they use UDP. And so these guys are using UDP, RADIUS. And it's very simple. Basically, there are 3 entities. One is the user, second is the network access server. This is the modem pool. This is the first point where you connect to the network. And in case of wireless networks, this would be what point where you connect to the network? Access point. So that would be the access point. R in the case of an Ethernet network could be the switch, the first switch on the behind the port that you connect to. So where is the first point in the network? That is what is the access server. And then in the back somewhere miles away is the radius server. It is called authentication server. So authentication server has a database which is shown here by this. And the messages take place something between the user and the server, access server, and then something between the access server and the authentication server. Okay, this is called NAS, Network Access Server. This is called AS, just to be sure, NAS. Anyway, so for example, this person comes on and says, hey, I am Raj Jain, and I need to connect. Then from that information, which probably will have Jain at AT&T.com or whatever, the access server will know that we should send the request to authentication server and say, well, Jain at AT&T.com wants to authenticate, what do I do? So then this will give a response which says challenge. Send this challenge to the user. That access server passes on that challenge to the user sends the response, and that response is sent back to the server, and the server says it looks good, it's okay. Alright, so there are only 4 commands. One is request, second is challenge, third is accept, there could be 4th one which is reject. The format is that the first byte is code, second byte is the sequence number, identifies the sequence number, third is length, and then whatever information belongs to that code is here, and the other attributes. Now, code is the only thing that access server needs to know, nothing more than that, because it doesn't look at any of this stuff. And the codes are: 1 is a request, 2 is accept, 3 is reject, 4 is blah blah blah, all of those things, right? So the interesting thing is that this modem pool, which is really a dumb device, any access point, in that sense, is not as smart as this authentication server, and doesn't understand cryptography and doesn't understand anything. All it has to do is just act as a relay. Whatever it gets, it sends there, it says, well, this is, and sends there, and whenever something comes back, it looks at the code. If the code says 1, that means it is a request. If code says whatever number 3 was accept, I think, it says 3, it says, okay, you're fine. So it doesn't even understand what the challenge is. For example, it doesn't know what the challenge is, and it doesn't need to know, because whatever comes and it says code challenge, it just passes it on to the user. Here is your challenge. When the response comes back, it passes on to the server. So NAS can be very simple. Is that clear? The idea behind radius server, radius, is that all the intelligence, all the cryptography, all the security stuff is kept here. And the NASes are very large in numbers. I mean, you will have at one airport maybe hundreds of access points, and in one city, many different dial-in numbers. Right? At every point they need a NAS, and the NAS should be simple that way, and all the complexity is done here. Okay? Now there is not much more to this in radius than this, but basically the idea is clear, the basic idea that we want to make the access server, the network access server, which are large in numbers, to be very simple, so all they understand is the code. 1, 2, 3, 4, 256 codes. And they don't read the rest of it. And the identifier, of course, they read, so they know that this is a response and a challenge, for that message that was sent. So we talked about authentication, but they also do accounting. So if the accounting request comes in, then it sends the accounting response, and then there are a few other things such as whether the client is still connected and things like that. You want to find out. So those are not part of the standard. So the standard comes in two pieces. One is experimental piece and the standard piece. Is that everybody implements it. Experimental is they just try to see if this will work. So actually everything that is developed in IETF has that flavor, is that when, for example, TCP was invented, first few years it was in the experimental phase. There were many more features, and then 1 or 2 years later they make it a standard, and then they remove some features which were not used, and then add some features which will be in experimental state for the next few years. You will get a challenge, and you will send a response to that challenge. That challenge will be response will be called access request again here. So you see, there is no such thing called access response. Okay, so basically, first you give your name, and that makes an access request just with your name in it. And it goes there, then it sends an access challenge. Somehow it knows, let's say it is going to use your password for authentication. In that case, it will say, okay, here is my challenge, what is your password? That will be passed on here to the user. And the user will say, my password is such and such. That will come here, it will be sent back. So the NAS is not reading any of these two things. Now it will match the password and will say, okay, all right, it's okay, good. So accounting we already talked about. Accounting start packet at the service beginning, accounting stop packet at the end, client sends to the server, and all packets are agged by the server. So here actually the client really means the NAS, because the user is not really talking at all to the server here. They are just talking to each other. And the user is not even aware of the authentication server. The user is talking to this. So basically one could say that the NAS sends to the authentication server, accounting start, accounting stop, and those packets are agged. And packet format is same as in authentication, which was this. Now, RADIUS has been around for quite many years, around 1994 or 95, I think. So obviously in 15 or more years, there have been changes. And so there's a whole bunch of problems that came up. And so this and the next slide talk about what the problems are. First of all, it does not allow anything for server to initiate any messages. All right, everything server only responds. All right. So that way it cannot do on-demand authentication or disconnect. So suppose an hour later it's found out that his time is over, he no longer is paid, now we should stop him. Server cannot stop because there is no message which server can send. Does not define data object security mechanism, and so it does not define how the security, I want to go back, how the security works between these two, right, between the NAS and AS. Now obviously you will have some kind of protocol between them so that the things are encrypted on the internet and they're decrypted at the NAS, but that is all not defined. First set of problems is does not define a standard for failover mechanism. So everybody has implemented differently as to how do you fail over if you can't find the RADIUS server. Second thing is the original RADIUS defines only integrity for the response packets. So only response packets were protected by integrity, but not the other packets. Does not support per packet confidentiality. So whatever key you negotiate in the beginning, you use that key forever, which is kind of not very good. Billing protection is assumed in the server, not provided by the protocol. So if the same billing data is sent twice, then it is assumed that the server somehow knows that this is a repeat of the previous billing and not a new billing record. For example, if you say that the server, the person has used up 1 hour, and then you send another person, the same person has used 1 hour, the server has to somehow figure out whether these are the same 1 hour or different 1 hour. So replay protection is assumed in the server. IPsec is optional. So the security is not really required. Runs on UDP, and therefore everybody makes their own way of making it reliable. And radius does not define expected behavior of proxies, redirects, and relays. So all of these things are just, everybody has done their own way, every company. So you buy Cisco's radius server, it may be different than some other company's radius server. And the list continues. It does not allow server-initiated messages, does not define data object security mechanism, does not support error messages, does not support capability negotiation. So, for example, it cannot ask the user, please tell me which of the things you support, right? No mandatory or non-mandatory flags for attributes. And server name addresses should be manually configured in the clients and administrative burden. So the NAS will have to really know where the radius server is, and this has to be manually put. So there is no command for the NAS to discover the radius server. So the reason all these problems have been well documented is because somebody is thinking of the next generation, and that next generation is called diameter. Now this is a play on the words. Diameter doesn't stand for anything. Because the previous one was called radius, the second generation radius is called diameter. So it is enhanced radius, lightweight, and they have taken care of all those problems that we listed in the last two slides. So you can use UDP, TCP, and SCTP. I don't know how many of you have heard of SCTP, Stream Control Transmission Protocol. One. All right. So there have been very few new changes in the internet in the last 20, 30 years since it started. And one of the things that really went through is SCTP. So there have been many, many attempts to replace TCP. There are many problems with TCP. There have been many attempts. They have not succeeded. Only SCTP is the one that can claim to have come in as a replacement for TCP. I mean, as a competitor, not replacement, as a competitor for TCP. So there are many applications that do not use UDP and TCP, they use SCTP. Right? It's another transport protocol. It has several features that TCP does not provide, including multi-homing and other things. I will not go there here. But basically, the diameter can use either one of those three transport protocols. PDU format, is connection oriented. I think so. I mean, I will have to check it myself because this is like 4 or 5 years old. It's not very old. And so my thinking is that it is connection oriented. PDU format incompatible with radius. So I mean, again, just like this is next generation, but does not talk to the radius. Can coexist with radius in the same network. So it can coexist. So people can talk to radius and then they can talk to diameter, but I don't think a same message can be sent to both. Defines a standard failover mechanism, supports attribute value pair. So basically, many of the messages have been made programmable or extendable, and whenever you want to make something extendable, you use TLV, type, length, and value, and that is what is also called attribute value pair, AVP. You just code that way, is the type, length, and value. Capability negotiation. Just we talked about that it was missing from the radius. Error notification, ability to add new commands and AVPs, discovery of servers by DNS, so you can send a DNS request to who is the radius server for this domain. And dynamic session key derivation by TLS, and it also supports TLS to find the security key, secret keys. Anyway, that is another web page in Wikipedia. All data is delivered in the form of AVPs. AVP again is attribute value pair, which is TLV, type, length, and value. AVPs have mandatory and non-mandatory bit. So basically, when you send a type, length, and value, I think we had another case some before where one bit was encoded as fault or warning. So similarly here, if that bit is set, then you will, if you don't understand it, you throw away the whole message, and if it is non-mandatory, then you can just read the rest of the message. So support for vendor specific, so vendors can extend it with some more TLVs, attribute value pairs. Authentication and privacy for policy messages. So authentication simply means that MAC, the message authentication code, and privacy means encryption. For some messages that have to be sent, there is encryption and integrity. Peer-to-peer protocol, any notification request. So now this is totally peer-to-peer as opposed to the RADIUS, which is client-to-server. Right? Here, either one can talk to the other side. Servers can send unsolicited messages to the clients. And again, here client doesn't mean the user, client means NAS. Document, so there are many standard documents. There is a base standard document, there is a transport profile document, there is an applications document, and all of these means that there are many RFCs. There are lots of RFCs on diameter. In fact, there are lots of RFCs on RADIUS as well. I did not put the list of the RFCs because if you go through them, it is too much to read. I think what is in the Wikipedia is sufficient for this course. So I just left the Wikipedia pointers. So the applications document include how to talk to NAS, how to do mobile IP, how to do credit control, prepaid, postpaid, credit driven, how to use it on 3G, how to use it on EAP, and how to use it with SIP. I don't know if any of these protocols want to know about. Everybody knows what is 3G, right? It is very difficult to not know that in these days of mobile telephony. SIP, Session Initiation Protocol, that is used for VoIP. Whenever you want to start a VoIP session, a SIP message is sent to start that session. So this can be used for many other purposes, basically, this diameter. Okay, I think that finishes the RADIUS and diameter. All right, so what we did was, basically, we started with RADIUS. RADIUS is a simple protocol where you just have messages which are forwarded by the NAS, and that way we can authenticate the users, regardless of where they are. Then RADIUS had some problems, so we talked about diameter, and the diameter makes it more general in every respect, including what transport it uses, what messages it allows, what attributes it allows, who can talk to whom, and so on. All right. Now, having said that, I have not seen too many diameter servers either. So the fact that WashU is replacing its RADIUS server this week, I think they're replacing it with some more RADIUS servers. So that means that the diameter is here but not here kind of thing, Diameter, actually, I remember going to diameter meetings about 10 years ago, more than 10 years ago. So it could be pre-2000. But that is the fate of many of the IET, many of the internet protocols. It is very difficult to incorporate a change or adopt a new protocol. And now let me tell you one more thing about SCTP. The reason SCTP came in is not because IETF wanted it or people were. It has a totally different application. SCTP is being adopted by the carriers for VoIP and other things. And so there were no transport available at that time that could take. UDP was not good enough and TCP was not good enough. And so the new applications started using the SCTP, and that's how it came in. So that finishes what we call remote authentication. Now I'm going to talk about somewhat not so remote authentication. Okay, I don't want to call it local authentication, but we'll start with local authentication first, and then we see how do we do it over the network. So the simplest life in the world was when you just had a password authentication. Right now when you log onto your computer, you're doing password authentication. It says what is your username, what is your password. So that is password authentication protocol, PAP. Basically, you send an authentication request and you send your username and password in the clear. Right? So this is not very good for the network applications, but it is good for the local authentication. And the messages are basically, there is a code, there is an ID, length, name length, name value, password length, password value. All right? And then similarly the response would be success or failure. It's a very simple protocol, was good for a time, but it is no longer used. Obviously, you cannot go with this protocol anywhere outside of your control. You can probably use it between your labs, inside your labs, where there are two computers sitting here next to each other. But as long as you go out of your control, this is very insecure. So they invented CHAP. CHAP is Challenge Handshake Authentication Protocol. And here you don't have to send your password on the line. What you do is, even if you have a password, we don't ask you for a password, we send you a challenge. We send you a number, we send you a text. You do something with your password and that text. And you send it back. I know your password, so I can do the same thing and I can compare, and if it's okay, then I know you know the password. As long as you know the password, you are okay. So that is called Challenge Handshake. Challenge Handshake Authentication Protocol, CHAP. So now the password doesn't ever go on the wire. And so authenticator sends a challenge, the peer responds with MD5 checksum hash of the challenge, obviously using the key. Authenticator also calculates the hash and then success or failure, requires both sides know the password in plain text, and replay or text prevention is basically you have to send a different challenge every time. So you don't use the same challenge, because somebody can record the challenge and the response and they can use it. If the same challenge comes back, same response can go back. Right? So you don't use the same challenge any time again. So that's very simple. The next thing is, how does Microsoft do it? These things. So Microsoft, and it is important because Microsoft means you, we, everybody in everyday usage use this. So Microsoft has a version of CHAP called MS-CHAP, which is also described in some RFCs. And it is similar to the previous CHAP, but then there are some details that Microsoft selected itself. So instead of password, they use the hash of the password. So all you need to know is the hash of your password, not the real password. And they know only hash of the password. They don't know the real password either. So the challenge is 8 byte long, 64-bit. And the response is 24 byte when it is in the LAN manager. And in the NT, it is 24 byte and a 1 byte flag. So anyway, so 24 or 25 byte is the response for 8 bytes. And in the original LAN manager, your password was limited to 14 case-insensitive characters. This is old actually. Nowadays, everything is case-sensitive. Previously, the passwords were not case-sensitive. Right? That was the old LAN manager, LM. Now with NT coming in, things are not only case sensitive, but there are 256 characters you can use, Unicode characters. So you could use semicolon and whatnot, and they force you to use all of those things, right? And so now there is many more possibilities. And I did not put here as to how long they are supposed to be. And I think it could be more than 14, but if it is 14, then 14 raised to 256. 256 raised to 14, sorry. 256 raised to 14 is a big number of possible passwords. Anyway, flags, so there are the flags here in the response, and they have some meaning, and we don't really need to know all that. But the thing is that even that is now, CHAP is gone, CHAP version 2 is here from Windows 2000 onwards. And it's not really important to know the details of this right now. It's all it is important. This is how the authentication was or is done, because you really want to move to the next step. And to go to the next step, it's important to know how it was done before. So that's why I'm giving this some of these historical things. So the next step is EAP. All right, so EAP, I'm going to come to EAP in a minute, but basically this PAP and CHAP were the authentication protocols in the past. And actually, why I should say in the past, they're in the present as well. Today, even in Windows 7, you use some version of CHAP. So it's all there. Particularly when you do domain login, your password or hash is sent to the domain manager and something is done, right? So that is all this CHAP stuff.